don't really need an introduction. So if you don't know them, please find out. It's a simple search term called LinkedIn and Sailesh Kumar, and you can write either Jio or Ola or FICO or Google, any of them, and that'll be the first profile to come up, right? But suffice it to say that Sailesh has worked on every kind of problem that most of us can imagine, simple systems to extremely complex ones to multi-layered systems. And right now, he is working on, I think, his tagline says AI for the world. Is this what it says, Sailesh?
AI for India, building AI for India.
AI for India. Okay, so close enough as a metaphor.
Yes.
And if he decides to talk about a little bit about what he's doing, you'll find out that that's truly the case. And I think if you have questions about what it takes to be one or to work on problems like that, do think about this and ask these questions, because you're not going to get these chances very frequently to people like Sailesh who really represent the AI map in its entire scope. People get to work on something or the other. Sailesh was at the game when it started, right? I mean, we're talking so early 90s. So and he's been involved at its very outer edge, bleeding edge, cutting edge, whatever edge you want to call it, right through, including all the names that you've heard of. So he's worked for Yahoo, he's worked for Microsoft, he's worked for Google, he's worked for Ola, grand Indian startup. Now he is at Jio, which is now sort of rewriting a chapter in high-end technology in India. So with that, over to you, Sailesh.
Thank you, Siddharth. When I hear my intro, I feel like, oh, who is he talking about, right? So thank you for all that. All right, great. So let me share my screen and give some context as we talk about things. All right. So thank you for inviting me. This is obviously a very wonderful forum and a very good opportunity to learn about some of the amazing things that are possible with AI and what role we can play in this context, right? So let me just hide this thing. Okay. So, there are different types of talks that I give. And, this one, I wanted to highlight a couple of things. I wanted to talk about conversation systems, go a little deeper, organize the space of conversation systems and say, what are the N levels of conversation systems? And then talk about two big ideas. One is what I call reasoning-based conversation systems, and an application which is diagnosing a disease based on a conversation between a doctor and a patient. So I want to give you two flavors within a structured organization of this beautiful theme called conversation system. And obviously, why conversation systems? Let me just share a video with you. This is a video from Star Trek. Obviously, just imagine conversations in the future. So if you are 300 years in the future, think of this as a possible conversation. This will give you a lot of ideas and imagination of where we are, where we need to go, what is the full potential of a conversation system. So let's watch this. Hopefully the audio will come. We'll not watch the whole video, but this will give you a good starting point. Let me know if the audio is not coming.
Computer, interface with the Midas array. Activate the control matrix.
Matrix activated.
Full power to the graviton emitters.
Emitters powering.
Scan the area surrounding the array for a Class B itinerant pulsar.
A pulsar has been detected at coordinates 227 by 41 Mark 6.
Good. Direct a 60 terawatt tachyon beam toward the pulsar.
Tachyon beam initiated.
How long until levels are sufficient to produce a gravimetric surge of 5 million teradynes?
Approximately 17 minutes.
Is there a micro wormhole present at coordinates 343 by 27?
Scanning. Affirmative.
I knew it. Adjust phase alignment to direct the wormhole's trajectory to Delta Quadrant grid.
All right. So hopefully that gave us a good idea of what a full-fledged conversation system looks like. And this is an intergalactic conversation system. The scientist is actually talking to a system, giving it instructions, asking to make an estimate of something, right? Asking a simple question, complex question, giving an instruction, receiving an answer, asking it to do some reasoning and calculation. And there's a system that is working, which is guided by both speech, language, understanding, and reasoning and actions, right? So this is kind of the full scope of what a conversation system could look like. So with that as a context of where we want to go, let me now talk about what, how we think about it. So if you look around, there are 4 big paradigm shifts that are happening. So the first paradigm shift is that we are going away from a document-centric world or a document-centric mindset to a knowledge-centric mindset. So if you look at Google, it was a corpus-based search engine. Now you have a lot of knowledge graph as part of it. And the reason is the world is actually not made up of documents or tweets or blogs or videos or images. The world is actually made up of events and attributes and relationships and ontologies. So the right way to think about data science is to first start thinking about modeling the real world as a knowledge graph, right? So the knowledge graph and knowledge-centric thinking is going to be a very big paradigm shift as opposed to purely corpus-centric thinking. The second big paradigm, and this is one of the big mistakes that Google made, which is it remained a search engine. It never became an action engine. And so what happened, you could search for a flight, but you cannot book a flight. You can search for a movie, but you cannot book a movie on Google. So then that led to good or bad, that led to a plethora of other applications to become action-centric. So people don't want information anymore. People want actions now. So ideally, Google should become an organizer of actions and not just an organizer of information. So this is a big shift that is happening. The third shift that is happening is that we are currently living in a very app-centric world. If you want to order pizza, you don't actually order pizza. What do? You first look for an app. Should I go to Zomato? Should I go to Swiggy? Then we order pizza. You don't watch a movie directly. What do? You go for one of the apps, Netflix, Amazon, whatever, and then you watch a movie. Now imagine if we switch this completely and say you are not surrounded by a bunch of apps. They guard you and they decide what kind of things you can do versus a reverse of this, which is, can I think of a universal personal assistant that understands you, that understands the content, that understands all actions possible, that understands the context of the world, the location you are in, the time that is going on, the coupons that are out there, and then brings all of this holistically to you and not one app for one thing, one app for one thing, one app for one thing. So this is another big paradigm shift that I see. And the fourth paradigm shift is that we are moving away from touch-based, beautiful apps with clicks and swipes and keyboards to speech-based, vision-based kind of interfaces. Because a lot of people who don't understand English, who are not tech-savvy, want a speech-enabled interface and not a very complex visual interface, right? So hopefully we are going to see this paradigm shift and we are seeing some more are coming. Everybody wants to build a personal assistant. All interfaces are becoming speech-enabled, Alexa, Siri, and all of that. And we're going to see this migration. So one of the contexts I want to set here is whenever you are in a field that is very fast moving, keep an eye on what is coming next, right? You don't want to become a old person in a new field. So these are the big context switches. And with that, the fourth one, I'll talk about conversation systems today. So if you think about the interfaces between humans and machines, they have evolved, right? And today we are in a speech-enabled, conversation-enabled world. And my prediction is that in the next 5 years, there won't be any keyboards required. Keyboards will not be required because as you speak, the system will type. As you, and the Grammarlys of the world, the spell corrections of the world will take care of corrections. GPT-3 of the world will actually generate a lot of text and you're going to only modify. So there's a lot of new things that are coming on the horizon in the world of how we interact with the machines, how we create and how we understand language, speech, everything else, images and videos. So think of that future and our interfaces will be very different as we go along. Yeah. Now, let me talk a little bit coming down to what a conversation system is and how do you think about the space of a conversation system? How do you put it as a point where, these are the aspects to consider? So the first aspect of a conversation system is who started it. Is it a pull system or a push system? So if I get an unsolicited advice from my bank that says, take this credit card, or from Flipkart that says, here is a nice product for you. That's a push system because the system started, human is consuming, or it's a pull system which says, I need to order pizza, I need to order a cab. So that's a pull system. So depending on who starts it, you can have a pull versus push conversation system. How is the flow? Is it very linear? Is it branching, right? So if I look at yatra.com, it's a very linear flow. If I look at an IVR system, it's a very branching. Press 1 for this, 2 for that. And within that, again, press 1 for this, 2 for that. So you can have a linear or a branching conversation. Third aspect is, does the user matter? Is the conversation completely generic or is it personalized to you? And that's a very important next evolution of a conversation system. Today, most conversation systems are very static, but now they can become more and more personalized. The next is, does the context matter? Depending on the location, does the context matter? So I want you to imagine if you are in Agra and you're somewhere and you say, I want to go to Taj Mahal, then it should order a cab for you. But if you are in Delhi or if you are in Mumbai, and if you say, I want to go see Taj Mahal, it should actually order a flight for you. So that is context, right? Where you are, what is the day of week, what is the time of day, and personalization, which is who you are, what are your likes and dislikes. Can a conversation system become context aware and user aware? So these are some of the futuristic ideas of a conversation system. Does the state matter? So what have you done so far in the conversation? Does that matter? Do you carry that forward? Or is it completely stateless and it doesn't matter at all, right? So how do you think about state thinking in a conversation system? And lastly, does it adapt? Is it very static? What have you done as a conversation so far? Does it affect the future path of your conversation? Or is it the same conversation? No matter what you do, is it the same conversation? So we're going to look at conversation systems from multiple lenses, and hopefully this will give us a more deeper understanding and a breadth of understanding around what a conversation system's full potential is. So what I've done, I've looked at this idea of conversations and said, look, there are simple conversations to complex conversation. Let me create a levels, right? Like you have a levels of autonomous vehicles. I said, let's create a levels of conversation systems. And you will see that some of them we already do. Some of them are not yet there. But I'm trying to organize the space of conversation system because it's a very chaotic space. So what is a level 1 conversation system is, in my mind, all the alerts and notifications and advisories and reminders that you keep getting automatically is a very simple conversation system. The system is trying to converse with you and giving you advisories and notifications, right? Level 2 conversation system is what we call a search engine, whether it's a structured search. Here you are pulling information or action, products to buy, songs to listen to, news to about a person. So when you're doing search, this is like a level 2 conversation system, and that's what the search engines are in all the different verticals. Level 3 conversation system, in my mind, is slightly more complex. Search is very easy because now we know how to match a question to a document or a keyword or a query to a document. But factoid question answering, text to intent, these are now the next level things going on in a conversation system. I don't want a document. I want an answer. So if I say, what is the capital of India? Don't give me 10,000 documents which contain the answer. Just give me the answer because I have no time to click and find the answer, right? So how do we go from search mindset to question answering mindset? It's an evolution in our conversation thinking. The next is, instead of a simple factoid question, can I actually do a reasoning-based question? And this is where we'll spend some time on, which is, how do we think about reasoning-based question answers? Why has Google and Bing and all these big companies have not yet cracked it? What is it that makes this level 4 chatbot a very difficult chatbot? But if we crack this, I think we're going to make a beautiful leap in the world of AI. So this is one of the areas that I'm very passionate about, reasoning, and reasoning about knowledge, reasoning about physics, reasoning about chemistry, reasoning about biology, reasoning about climate change. So how do we think about reasoning as a paradigm? And I'm just using that here as one example of reasoning-based question answering. The level 5 is what we call a static, stateless, linear conversation. These are very static. They don't change. They're not about questions and answers. They're about a set of steps that you have to do. For example, booking a flight. So it's a static, stateless, linear conversation. No matter what you have entered, right? The next thing will still be the same kind of a form with fields that are filled. It doesn't change because you have answered a different question. It goes through the same static linear conversation. Then instead of linear, can it be branching? Press 1 for this, press 2 for that. Then we become a IVR system, and then it has a branching factor going on. The next one is what, again, I'll spend a lot of time on, which is a dynamic stateful conversation, which means the conversation is evolving as a function of what you have said so far. Therefore, I'm going to ask you a next question. And this is where we are going to use diagnosis as a service. The question and answer that happens between a doctor and a patient is a dynamic, stateful conversation. So we'll see what that is. So this is the application that I want to share. Lastly, we will talk about personalized, contextual, and then dynamic conversation. So here we'll talk about advisory to a farmer, which is based on personalized and contextual advisory, which is very different every day, right? And how is it dynamic? So let's talk about some of these in a shallow way, some of these in a deeper way. And we'll spend more time on these 3 conversation systems today. Yeah? So level 1, we all understand alerts and notification. Even your car dashboard that says your car fuel is low is also a conversation, right? A message you get from a bank is also a conversation system, whether it's an alert or a notification. If you get notification about your food is delivered or whatever, or 25% off, or a new song has come, these are all level 1 conversation. If you get a reminder, don't worry, this is not a actual thing. This is, you're not having a meeting now in 5 minutes, but this is an example of a conversation system. A lot of health apps are producing reminders for people to say, this is what you need to do next, especially old people who take a lot of medicines, flight reminders and all that. These are also conversation systems. Advisories, right? Today we can generate a lot of advisory for farmers, for pesticide, for fertilizer, what you need to do, or weather advisories, right? It's going to rain, it's going to flood, advisories for all kinds of reasons, right? So these are all examples of level 1 push conversation system. The second is unstructured search. We all know structured and unstructured search, right? So the idea is you search for a product and you have fields that you can select and say, I need this, or I need this kind of a property, or I'm looking for this kind of a flight. So these are what we call structured search. Unstructured search, we all know. And now unstructured search is moving to other areas also. I can actually search by a photo. So in the middle, there is a photo of a person. And if I take a photo, then I should be able to search by an image. So this is all fashion industry. Similarly, a farmer can take a picture of a crop and say what disease it is. So this is image-based, text-based, audio-based, like humming of a bird, humming of a song, you can search. So this is all unstructured search. So this is also a type of conversation, which is involving a query and a response. Now we go to factoid question answering. Now here, today, now, thank God, after 10 years of Google, they started doing what we call a knowledge graph. And now if you type Prime Minister of India, you will see 10,000 pages, but you will also see the answer right there. And these are all screenshots from Google searches. And now you can see, properties or, what you call attributes of entities, right? Director of the movie, right? How old is something? What is the capital of something, right? When was somebody born? These are what we call factoid questions. They are present as is in the knowledge graph. All you have to do is, instead of running a Elastic search on a document corpus, you are running a query on a knowledge graph. So knowledge graph based question answering is now becoming very common. Alexa, Siri, everybody's using this kind of a conversation system. So this is a very important skill set to learn, knowledge graphs, and how to use them to answer these questions. And what do they do? You have a book, you have a whole, knowledge graph of people, books, images, and their attributes. And when somebody is asking who wrote The Art of War, you say book, authored by, and person, and you retrieve that, right? So it's a very simple language, and there are many graph databases who can now help you do this. So these are factoid based question answer. Now, all these 4 or 5 things are very easy. They are already done. We don't need to do much, but knowledge graph is something we need to learn about. Then you can also have collections of answers, right? Give me all the type of arts that are out there. Give me all the movies by a person. So you can have a list as an answer and not a fact as an answer. So you can do complex things. These are not driven by traditional search engine. These are driven by knowledge graph, right? Give me a list of all entities of type, art, style. Give me a list of all movies where Amitabh Bachchan was a main actor, right? So these are all interesting search. So what is a knowledge graph? What is knowledge graph thinking? It's a very important kind of thinking. We all think we have built a deep learning model, so we are data scientists. No, there's a lot more that we need to learn. Knowledge graph is a very big area. How do we think about knowledge representation, right? What is an entity? What are its attributes? What are its relationship to other entities? How do we think about the name and the ID as two different things? You have a name, you have an Aadhaar card. Your Aadhaar card is your ID. Name can be same for many things, right? How do you think about features you have extracted for a person, for a context? How do you put them in the knowledge graph? How do you think about models associated with an entity, right? If you're an entity person and you have a resume, I can think of HR models, job matching models, right? Or Shadi.com models, or pizza delivery or personalization models, right? Associated with an entity. How do you think about actions associated with an entity, right? So with food, actions could be book a restaurant, deliver. For movie, the action could be, watch on Netflix or go to a theater, right? So depending on the entity, what are the actions associated? And what are the different content associated with that entity, right? So when we think of knowledge graph very holistically, not in the current definition of knowledge graph, I'm expanding the scope. And now we can think of knowledge graph is a way of thinking. It's a very powerful construct. And now we'll see how to use it even better, right? So within knowledge graph, if you think about static attributes, right? What is the atomic mass of an element? What is the lat long of a cell tower? What is the date of birth of a person? So these are static attributes. You see them on Amazon pages or all the encyclopedia pages, right? Then you can have operational knowledge, right? If a customer has changed their address or a data plan, or a cell tower has changed the tilt, or a refinery unit has increased the temperature, how do you store that knowledge, which is a lot more operational in nature? How do you think about the context? Medicine, dosage of a medicine is a function of the age group or customer experience in this location, or what is the way to create sambar in a Tamil Nadu style versus a Andhra style. So these are all contextual notions of attributes. And then how do you think about dynamic attributes which are changing? What is the GDP of a country? It's not a constant. It's a function of the year, right? Or literacy rate or the population. Similarly, what is the engagement of a customer in a business? Again, it's not static. It's a changing, right? Crude price and all that daily. So attributes are dynamic and predicates are dynamic. Again, I don't want to go into this, but the idea is there's a whole talk I could give on knowledge graphs and how do we think about knowledge as a foundation infrastructure for AI. Yeah. All right. So now I'll spend some more time on this, which is reasoning-based question answering. And why is that a beautiful problem? Why is it a difficult problem? Hopefully, if some of you are excited about it, talk to me. We can work together. I have a very large reasoning team that we are working on, different kinds of reasoning. Right? So let me ask a very simple question. Which is the longest river in India? Now, when you answer this question, and imagine if this answer is not present in the knowledge graph as is, what will the knowledge graph do to find this answer? That is called reasoning. So it's not look up, it's reasoning. Right? So if you understand that difference, so first it will interpret the question and say, okay, you are looking for an entity of type river. You are looking for max of length. You are looking for the answer is, your answer is an entity type of river. That's what your answer should look like. The predicate do you have is in a country has river, which is India and country. So this is how you understand the question first. And this is a completely different skill set, right? Using the knowledge graph, annotating the keywords, India, river, longest, and all that, you can understand. So this is the NLP part of the reasoning engine. And then the second part, which is where the next big innovation in AI will come, which is how do you generate this program, which says, first, give me all the rivers in India, then give me all their lengths, and then the answer is argmax of that set, right? So now the question is, you are given an NLP question, you are supposed to understand it, and you're supposed to generate this program. Once you generate this program in terms of the basic building blocks, which is get objects for a predicate, get attributes for an entity, do some math calculation. These are primitives available to you. But on top of that, you have to build a conversation reasoning system, right? So let me give you one more example. Then we'll talk about why this is a difficult problem. So let's say if I ask you, which was the highest grossing movie of Amitabh Bachchan last year? Now, this is a reasoning question. The answer is not there in the knowledge graph. So what do? We interpret the question and we say you are looking for a movie, right? Highest means, it's an aggregate max function. Grossing means movie revenue. A movie as in movie type, entity type. Predicate is person acted in movie. The person himself is Amitabh Bachchan is an entity. And last year is an attribute of a movie release date. Now you have understood the question. Now what do you do with it? Now, a lot of people who are very, embedded to embeddings, if you will, they say embeddings will solve this. This is not an embedding question. All problems in NLP are not embedding problems. Somehow Google got lucky that we created thought vectors and paragraph vectors, but that tool is for something else. It cannot answer reasoning questions like this. And, therefore, this is very important to understand the approach we take for different kinds of problems, right? So here, what do we need to do to solve this problem? We take this question and we generate a program, reasoning program, right? So which says, give me all movies by Amitabh Bachchan, then give me all their release years, then filter out only those movies that are in year 2021, then give me the revenue of only those movies, and then, give me the argmax or the top scoring in terms of that revenue. Now, why is reasoning-based conversation system a hard thing? Right? So that is the key question. And if you think about what we did, we interpreted the question, right? What are the entities, attributes, predicates, qualifiers? We analyzed the question. We generated a reasoning program from it. Then we generated an answer, which is a knowledge answer. And then we have to synthesize an answer in the language that you want. So that is a synthesis of it, right? So these are the 4 stages. But if I ask you, which is the hardest of these 4 problems, really, the hardest problem is this one. And this is the core reason why we have not been able to crack reasoning as a service, and we are still doing, factoid question answering, hand-created question answering, and matching your query to a question. We have not really cracked reasoning-based question answering. Now, if we could do this, we have a huge potential. Now imagine a pharma scientist can ask a question, which is a complicated reasoning question, and now we can accelerate his speed of innovation because the knowledge graph of medicine is there, and he can ask very deep questions, right? What will happen if I combine this molecule with this molecule in the context of an old person whose genome is like this? That's a very complex question. And now we are trying to build reasoning systems which can kind of answer those questions. And embeddings and deep learning has absolutely no place in this. Yeah. So one of my core insights is that we are going to create artificial general intelligence if we combine the 2 halves of AI. One is the reasoning half and one is the deep learning half. And these 2 are very important. Only one half is not going to crack this, right? So we need to develop both these skill sets and know when to use what. Yeah. Now, the reason why this whole thing is a difficult problem is because of the following, right? I'll just take a minute. Generating this program for every unique question is the unsolved problem. Understanding language is still easy, right? You can annotate stuff, NLP does it. But generating this program is the hard part, not executing this program. So what programmers do today, we write programs, right? But can AI actually generate a program that can then solve the answer? This is the meta world, really. So this is where we need to go with the reasoning-based thinking. Yeah. So hopefully that gives you a sense of how important this topic is and how amazing it will be if we can crack this in a general way. So today you cannot ask a general reasoning question on Google because nobody has a way to generate this, right? So now we have almost cracked this problem and hopefully we'll see some papers out. Now, coming back to a simpler one, linear workflows, we all understand. No matter what you do, who you are, what your context is, if you are going through a journey, it's very linear, it's very static, only the forms have changed, but the form filling has changed, but the journey is the same. So these are linear static workflows, is another type. Another one is conditional branching, which is how do you think about press 1 if you're a new user, press 2 if you're an existing user, and the journeys are different. So these are examples of branching-based systems. Yeah. Now let's talk about another area that I want to talk about, which is a dynamic stateful conversation system, right? And the idea is this is the work we have done with our mentor, Dr. Chetan Bhatt, who is a very senior doctor in Reliance Industries. And he has an idea about how to think about diagnosis. He's one of the world's best diagnosticians. That means if you talk to him for 3 minutes, he can tell you exactly what your disease is by asking you the relevant questions. He doesn't need to do any test. Just from symptoms, he can tell you what the problem is. So I met him and I said, sir, we need to build this AI program so that the whole country is suffering from lack of diagnosis as a service. And if we can release this in all Indian languages across the whole India, it'll be amazing, right? So we showed this to a National Health Authority. They're very excited and they want to put this on their website, right? So why do we need such a system? A lot of people are dying because of delayed diagnosis or wrong diagnosis, right? Diagnosis is a very difficult subject. It's very subjective. If the doctor knows about a disease, if he knows how to do reasoning through a combinatorial space of symptoms, only then it can happen. And now the problem is accentuated because if you look at the countries like India, South Africa and all that, they're not good doctors across the depth and breadth of the country, right? So plus the diversity of population is very high. North India diagnoses are different than South India. So that is the power of solving this problem. So what we need an AI-assisted diagnosis system, which is very holistic and understands all diseases. It is very precise. The top 3 must contain your final diagnosis, and we need to make it available in all Indian languages or all languages of the world, right? So how does the journey work? You have an initial symptoms. What do? You then come to this application. You say, I have fever. Then the system will go through a whole bunch of question answer. This is called preclinical diagnosis. Diagnosis before you take a test, right? Before a blood test, the doctor has to first make up their mind. What are the top 3, top 5 possible diagnosis based on only the symptom? That is called preclinical diagnosis. This is the hardest part in the medical world. Then if the system then says, okay, doctor, here is the diagnosis that AI is giving, the doctor agrees or disagrees or whatever, then we decide whether we need further investigation. Then we assist the doctor in saying, if you think it is malaria, dengue or whatever, these are the possible tests. The doctor agrees, the patient does it, he uploads the results. And then we get a post-clinical, which is after we have seen the reports, what is the final narrowed down diagnosis to 1 disease out of 5, which we thought were there in the first part. And then the doctor agrees that this is the final diagnosis. Then we go to prescription and say, if this is the disease, this is the patient, age, allergies, whatever, other medicines he is taking, then this is the medicine that is best for him, combination of medicines. Then doctor approves, right? This is the whole journey. And this is the hardest part. So here we are learning 2 things, right? Here we are learning how to take a complex, important problem for the country, think about it end to end, identify the core AI problem to be solved there, and then work on that for 2 years, right? So this is the result of that. Yeah? So what do? We basically say, here is a conversation from the patient, right? So we update the symptoms. He says fever, how long, how much. So we keep updating the symptom state. And then from symptom state, the first AI is given these combination of symptoms. What are the diseases possible? So now you have a disease vector with a probability score. So that is your disease state. So this is the current state of the conversation. This is a stateful, dynamic conversation, right? And it has an obvious part, which is symptoms, and a non-obvious part, which is the latent part, which is diseases, which is going on in the doctor's mind as he is having this conversation. And then what happens? At some point, the doctor is confident about his conversation or not. If he is confident, he'll tell you the diagnosis. If he's not, he's going to first ask you rule-based question. If you have fever, tell me how much, how long, does it come over in the night and all that. So there are rule-based questions. And then this is where the second type of AI kicks in, which is reasoning-based question. So if you have dengue versus malaria versus this as the top 3 potential diagnosis, what symptom should I ask you next so that I can discriminate between first and second? Or I can confirm the first, or I can see if second is really there or not. That is a very intelligent process. This is the reasoning in diagnosis system. Yeah. And then you can synthesize a question the patient can ask, right? So now we have a system that works with more than 10,000 units of knowledge between symptoms and diseases, 500 diseases in India, 500 diseases in symptoms that you can have. And now we have this is the result where we are now 99% accurate in the top 5, that our diagnosis is definitely there in the top 5. And remember, this is by just having a conversation with the patient, no tests, nothing. We can tell with 99% accuracy, this is the disease you have. It's one of the most sophisticated diagnosis systems in the world. The next one built by Babylon and others is only 70% accurate at precision at 3. And it asks many, many more questions. We ask very few questions and we get the thing very quickly, right? So this is how it works. One example. So you start the diagnosis, you say, what is your age and gender? You tell me the first 3 symptoms, fever, headache, and confusion or disorientation. And then what it does, fever-based questions. So these are fever-based questions. So how much fever, how long, these are supposed to be asked because you have said fever and there's a lot more going on. You have said headache. So again, how do you say what is So see, what is the conversation now? It is visual, it is menu based, it doesn't have to be NLP. Here, reasoning is more important than NLP. So we did not touch NLP part at all. We said, let's solve the reasoning first, then solve the NLP. And this is one more learning for all of us, which is how do we address the core problem, build the engine first, then build the chassis, and then build the exterior, right? We start building the exterior, NLP problem we solve for 2 years, and we don't have a handle on reasoning problem. So start with reasoning, NLP is easier. And then we said, okay, this is the thing. Again, more questions of attributes type, headache. Now this is where reasoning has kicked in. Now what has happened is, based on the first 2 set of answers, the conversation has, the AI system has figured out what might the top end diseases be. Therefore, what kind of question should I ask you next? So it is asking these questions to eliminate some diseases or to confirm some diseases. This is called differential diagnosis. How do you differentiate between top and second and third? And then, again, it is not satisfied. It is not converged. Again, it is asking, again, you are saying yes, no, yes, no. So these are all generated from AI. These are different. If you had started with some other symptoms, AI, this would have asked you a completely different set of questions, right? So this is dynamic and very contextual in that sense, right? And then again, it is asking some more, and you can start to see where it is going. If you are a doctor, you can start to see where it is going. And then finally, it will tell you that you have cerebral malaria, dengue, this and that, right? So this is how the system works. This will be launched soon. So everybody in the country should be able to figure out what their diseases are. And what goes on in the brain of the thing is this diagram, right? So initially, and this is a different triage. If you give me initial symptoms, I have this order of diseases. Then as you tell me the second symptom, I have changed, this has gone up. And then again, you told me the third symptom, or I have asked you whether you have this or not, and you said yes, then it became this symptom. And then, other diseases are going up and down. And now you can see that these are the final diseases. So the thought process that happens in a doctor's mind is also happening in a conversation system. Yeah, this is all reasoning. There's no deep learning here. Yeah, and we can build this because another last thing I want to talk about is personalized context advisory, contextual advisory. So the idea is you are a farmer at a particular lat long. You are asking a very specific question to an AI system. We need a speech to text. We need a text to intent. We need to create an AI-based agriculture expert. Farmer profile, which is contextual. Where are you? What crop are you growing? What is the soil type? What is the weather forecast? What is the soil IoT data telling me about your soil today? What is the knowledge graph of agriculture? What is the satellite data, weather data, soil IoT data? How do I combine all this and then generate an information that this is what you need to do? Content, this is how you should apply this pesticide. An action, I'm going to deliver this pesticide, don't worry. This is what we need to build instead of running a Krishi Darshan program for the next 100 years. We need to be able to build a personalized contextual advisory where the AI can ask a follow-up question and still give you a perfect advisory for that farmer. Yeah. So this is an example of not only dynamic, but also personalized and contextual. Yeah. So let me summarize. So the next generation conversation system will be reasoning heavy, not NLP heavy. And NLP conversation systems have all died now, right? There was a big hype and now they're gone because, people don't find them very useful. So they are dying because we need deeper conversation, which cannot happen if you stay superficial at if then else rules. You need to build reasoning systems behind them. Then the reasoning system is the key in my mind to artificial general intelligence. If you can generate a program, that is far more important. And you should be able to, AI should be able to generate the 3-question program, the 10-question program that a system can execute to give you the reasoning. So generating the plan for reasoning is going to become a very important innovation in the future. Thinking about differentiating between the observed state of the conversation and the latent state of the conversation, right? So symptoms are a latent observed state, you have already told me, but what doctor is thinking is the latent state. So together I generate the next question. Yeah. So how do you break that? How do you define confidence and convergence? How do you define efficiency of a conversation? How do you generate the next question which really increases your, decreases your ambiguity about the diseases, right? How do you generate the next question? And finally, how do you make all of this contextualized and personalized? So for example, if I have a question that says, did you have fever in the last 7 days? I should not have to ask you that question if I am integrated into your electronic health record. I should be able to do a lookup there. So that is the next generation out of this. Whatever we are showing, it is not yet integrated to your electronic health record. So once it is integrated, it won't ask all these stupid questions. It will ask them to your electronic health record. Yeah. Same thing with soil. I need personalized soil data for this farmer to give him the right advice. All right. So I'll stop there. Hopefully you got some deep insights about where the future is, what the paradigm shift is, when you think about conversation systems, which level you are, and what role reasoning plays in all this, and how do you can you build the next generation conversation system for an important problem, right? Not just to book an airline ticket or your haircut appointment. Can you actually do something deep with the conversation system? Yeah, like disease diagnosis. All right, so let me take questions now.
Thanks, Alish. Let me look up what questions are sticking around here.
Vrish has a live question.
Somebody has a live question.
Yeah, Vrish, go ahead.
Why don't we do that? We just ask people to raise hands. This is the last talk anyways, so let's do that.
Yeah, please go ahead. Yeah, Vrish.
Hello, sir. How are you?
Hi. Good.
So I have a couple of questions. So right now, in the diagnosis model, how are we generating the questions per, like how are we generating the questions right now?
Yes.
Is it just heuristics?
It is a very interesting heuristic. So first we talk to a doctor and say, how do you do it? And then we realize, oh, this is a very simple heuristic, but it has to be done across all 500 diseases, right? And the heuristic is, this is core IP that, we have created and filed some patents around this. But the idea is, think about how do you do decision trees? How do you decide what is the next feature to use? So you have a notion of ambiguity minimization, information maximization, right? What does that idea mean in the context of a diagnosis? So imagine you have a distribution of diseases, and now you are saying, which question will I ask so that no matter what the answer is, yes or no, the ambiguity will reduce, right? So that's your objective function to decide. And there are thousands and thousands of possible questions to be asked next. So therefore, you have to search that space.
So in this 500 dimensional latent space, you're basically splitting, and every split will have a list of questions.
It's not a truly decision tree kind of a thing. I'm giving you that analogy that the objective function for asking the next question is either to increase the score of the first disease from the second, or to move the second disease to the top, right? This is called differential diagnosis. How do you confirm that? So the first disease is 90%, second disease is 85%. So you need to be still able to increase the gap. Only then you are confident about your diagnosis. So that is the logic and objective function. And then we have coded up that logic in a very interesting way so that it generates the next question automatically. Yeah.
I had one more question.
Please go ahead.
So you spoke about conversational AI and how it can have personality and could be personalized for each and every user. So how are we thinking about this? Is it that we're just modeling an objective function for each agent of this conversational AI for, like, let's say for me, or
no. So one of the things we could do is, so think about it. Let's say let's say you're booking an airline ticket, and I know that in the past you like certain flights better, you like aisle seat, you like vegetarian food. So do I really have to ask that to you? Or should I skip that? Because I know it's like your personal assistant knows a little bit about you. So I don't have to have certain dumb questions asked again and again to you, right? That's one notion of personalization. Second notion of personalization is, if a farmer is asking how to grow soya bean in Madhya Pradesh and another farmer in UP with different weather and different soil, my recommendation will be very different, right? Because these if then else statements in the knowledge graph about soybean in different soil types and weather types are different. So I need to be able to give different answers, not the same answer. that is the personalized answer to the same question because the context is different. Yeah. So there are multiple notions of personalization, right? Third notion of personalization, like I said, is predictive personalization. So for example, in the future, we are going to have our longitudinal health record stored in one place with the ABA ID, right? What are we going to do with that? We should be able to predict that this is the disease that might happen to you. Now you have come in with a certain symptom, right? I have already predicted a certain disease. So your symptom combination and my prediction about your potential disease based on historical data should redo the personalization of the diseases for you. This is another notion of personalization, right? So there are many ideas that we can explore. So, work with us. You will be amazed how many things we can try in this
So
space.
we're thinking about it as updating the knowledge graph instead of updating the policy right now. But if we try
Not
to
only
update
knowledge graph is static, right? But your personal information, your profile plus knowledge graph plus state of the conversation so far together gives me the next thing.
Okay.
Are required. Yeah. Okay. Very good.
Thank you, sir.
Okay. Thank you. Anybody
Anyone else?
We are hiring. So, if you're interested in all this kind of stuff, feel free to send me. Yes, please. Go ahead, Bhaskar.
Sailesh, I'll contact you about the hiring bid.
Okay. Yes. Bhaskar, yeah, go ahead. Yeah, go ahead. Unmute. Then Vikash after that. Yeah. Yeah, go ahead, Bhaskar.
Yeah. Thank you. Thank you, Sailesh, for that knowledgeable presentation. And last time also I attended your presentation and I found them quite thorough in the sense the way you present to us. So my question here is from the metric perspective. So taking the example of the knowledge graph built for the diagnosis of diseases. So there, how are we accounting for the metric there? Because, for example, if we are saying that these are the 5 probable diseases that you could have, but going ahead, if the patient takes those diagnoses and none of them clears out, so how are we taking that into consideration? Are we doing any continual learning in that sense?
Yes. So there are 2 levels of learning in this, right? So one of the things I've learned is you cannot learn unless you have data, and you cannot have data unless you have launched a product. So you understand the problem? So the first version of the product is always knowledge-based, not data-driven. Yeah. Because we don't have this data yet in the country. Nobody has it. Now, once you launch this, what will happen? Data will come. Some diagnosis will be perfect. Some will not be perfect. Some will be the third diagnosis instead of the first diagnosis. All this will happen. Even today, Google search, people click on third result more than first result, right? So no system is perfect. Now, we have 2 check marks here. One is AI does not give you the diagnosis. The doctor has to approve it on top of it. So now imagine I give doctor the 5 diagnoses and the doctor selects the first and third and the 5th. That becomes label data for me, right? In a way, because the expert is now saying, okay, I've seen all the symptoms. This is what I think. And I'm a 50-year experienced doctor. So his weightage is more than somebody else. The second checkpoint is after the diagnosis that we gave, the patient went through the entire journey. And remember, we had a feedback loop that said, did you get cured or not eventually? Right? So if we had predicted a set of diagnoses and then we have suggested some investigation, prescribed some medicine, and you are okay after that, that becomes a continuous, right? And now imagine if we do that across the world, across the seasons, then it becomes further and further refined with, contextual data in different parts of the world, right? So this is kind of the next level journey, which is feedback loop is very critical and important, but you have to launch something to start collecting that data to start building the feedback loop. Yeah. So we now have plans to take feedback data and how to refine our heuristics, our knowledge, our whatever, so that it becomes fine-tuned for what we do today at a static global level. And then how do we do it in North India, South India, because GPS is coming along with every diagnosis, every such conversation. Yeah.
And one more question, Sayed.
Yes.
So in case of the farmer problem, so there we are giving a recommendation, and in case of medical diagnosis, we will get the result from the patient or even from the doctor as the label data. But in the farmer case, how are we incorporating that? Because, for example, if I gave, yes, the feedback loop there.
Yeah. So basically, I'm not imagining just one little advisory system. I'm imagining the entire ecosystem of agriculture, which includes, for example, satellite-based prediction of what really happened to your crop, right? Or I can say, hey, farmer, take a picture of your crop once a week. So I'm going to get that feedback from the farmer. See, AI is a symbiotic relationship with the user, right? If we stop using search engine, they don't improve. If we stop buying products at Amazon, it doesn't improve. So if the farmer doesn't participate and say, hey, you need to activate your phone and give me the pictures, you need to tell me what actually you did today, only then I can tell you that in this state, this action was right or wrong, right? So as the trust builds between farmer and AI, more interactions will happen. We need to imagine that future. Although it is not there, we need to imagine that that is the steady state we are heading towards. Yeah. And then how do we build system working backwards from that steady state? But you are completely right. We always need a feedback loop. Without a feedback loop, there is no AI. You can never build an end-to-end system and say, I'm done. Unless you tell me how to do version 2, given that you have launched version 1, how will you improve it? How will you collect label data? You've not built a complete AI platform yet. It's called induction in mathematics, right? If you know n, what is n plus 1? So n plus 1 in AI is very important. And what you're asking is very important for all of us to learn from. That how do you know that this is doing well? And how do you improve based on feedback data are very important questions in every AI system we'll ever build. Yeah. Okay, good.
If I could be given one more question. So
Sid, right. We have a long afternoon, so no problem. Yeah, I'm here.
So how do we decide on the retraining part of the model then? Because this
so
data,
you need to put together a trigger-based mechanism that says if the accuracy of the model has gone down by a certain threshold, or this is the new thing that is coming, which is if the data distribution has shifted, right? Or if the feature distribution has shifted, or if the model prediction output distribution has shifted, that means the entire population has moved. The priors have changed. So the old model is not valid. For example, pre-COVID prediction of my, demand forecasting of whatever in the city is not going to work in the post-COVID world because now people are moving around. So we need to decide when are those triggers. Either they're happening because real world has changed. We need to adopt, right? The economy, for example, when you think about the economy of the world or a country, the FICO score has a different distribution when the economy is doing good. The same score has gone down as a whole because the economy is doing bad. So how do you decide these trigger points is an art. Every domain has its own thing, but there are general guidelines, right? Feature drift, data drift, distribution drift, output drift, or model quality drift. So we need to be able to put these hooks in place to say time to retrain the model. Yeah.
Okay. Thank you, sir.
Thank you. Very good questions. Yeah, Vikash.
Hello, sir. How are you doing?
Yeah, good.
Sir, since you talked about diagnostic, disease diagnostic and application of AI in medical field, I am working for a startup which deals with healthcare, detecting diabetes and all. So I was curious about there is this lack of data in the field, and we have to often work with limited amount of data or very less amount of data. So I wanted to know whether you have also encountered such thing and how to deal with when you have very less data, say 4K or 5K only data.
Right. So see, we will always have this cold start problem in a new domain, in a new vertical. This problem gets accentuated because every hospital is very particular about their data. They don't want to share data because of privacy and ownership issue. So there is, as a startup, you have less data, but if you are part of a hospital and then you have more data. So one is solve the label data part, not the data problem. Solve the label data problem. You don't need 10,000 X-rays. You need labeled 10,000 X-rays. Yeah. So when you say what is data, data is labeled data is more important than just data. Second, when we didn't have data, what did we do? We started with knowledge-based systems. So we still have knowledge, domain knowledge, right? Like, in our world, we created a knowledge-based system based on medical textbooks, right? Or research papers published out there. So now you start with a knowledge-based system, launch it, it is reasonably accurate, right? And then you do your next thing. So for example, now this is not possible in the world of, for example, retinopathy or where computer vision is required, but when you train a, radiologist, he is trained with a few examples only, right? And then as he grows, his knowledge increases, but there is a cycle. He cannot be trained once and say, now you are trained, you're not going to be trained further. You're not going to learn anything now. He's continuously learning and improving. So we just need to reach a point of enough data to launch and not perfect the product and say there is always a human in the loop. When the model confidence is low, it always goes to a human. That is collected again. So that becomes your labeled data collection strategy. So you need to think about limited data, launch point, confidence scores, active learning, and then saying, okay, human label, how do I incorporate in my next cycle? You need to think about the cycle, not the end-to-end. This cycle thinking is important, which is missing in our way of thinking. Yeah. How do I improve the model next is more important than how do I build the first model. Remember this. Yeah. So then the thing will kick in, right? So hopefully, the data problems will go away when we have, addressed the privacy issues, when people have started trusting AI, when we as a community don't abuse the data for the wrong reasons, right? When we all are nice people, then AI will flourish. Yeah. Okay. All right. Thank you. Pooja.
Thank you.
Thank you.
Hello, Dr. Shailesh. It's great to be here. My question was, you mentioned knowledge graphs, right? And you mentioned about graph databases. So would you like maybe give a little more insight into how it has been incorporated in the diagnosis system that we talked about? And in terms of like mostly on a solution architecture perspective, and also the challenges one would have faced while implementing such solutions, right?
Yeah. So knowledge graph at a basic level, I showed you some examples of what is the knowledge graph as an API, not as a database. You can use any database, whether it's ArongoDB or Titan or Neo4j, it doesn't matter. APIs are important, right? Not the technology. Technology keeps evolving. Now, if you think about the core APIs, right? Give me the attribute of this entity in this context, or give me the predicate. Now, these are the high-level APIs available to you, no matter what domain you are.
Right.
Now, in our world, we created a knowledge base of symptoms and diseases. So we said, given a symptom, what are the diseases associated with it? And given a disease, what are the symptoms associated with it? So you have a two-way knowledge graph. There's a whole bunch of additional things we did, which we cannot talk about. But the idea is it's a two-entity system. And now we are going to add more entities, like what are the investigations associated with the disease? What are the medicines associated with the disease? What are the procedures associated with the disease? What are the body parts associated with the disease? What are the gene expressions associated with the disease? So the core skill we need is when we go into a domain like healthcare, the core skill we need is how to think in terms of a knowledge system of that domain. What are the entities? What are their attributes? What are their predicates? And then create a knowledge graph, not because you're solving a specific problem, but because there is domain knowledge, because it must be represented. Therefore, you must start with the knowledge graph of that domain. Yeah. So Google made a big mistake. It started with a search engine as a query to document matching. If it had started with a knowledge graph, it would have been much ahead. Yeah. We would have created knowledge systems in the world. Today, that knowledge is scattered. If you want to know the census data of a country, it's a knowledge graph. If you want to know which village speaks what language, what is the demographic, it's a knowledge graph. The medicine master of the pharmacy world is a knowledge graph, right? All the refineries, what are the parts, what are their attributes and relationship is a knowledge graph. So everything is knowledge. Knowledge representation is the starting point of AI. So that's the most important skill, not deep learning. Deep learning will come later. And that's only the other half. Yeah. And on top of knowledge graph, you can do a lot of things. Yeah.
Okay.
Yeah.
Yeah, thank you.
Thank you. All right, good. So no more hands raised. Sid,
It looks like not.
all right, over to you, man. Thank you.
Well, so I have a bunch of questions, but I think you and I can talk together about just general curiosity stuff.
Sure.
Right. And so thanks a ton. I hope all of you guys had a great time. Like every time Shailesh says something, he says something new. So I kind of love that. Right. And this whole this doctor system poses multiple interesting questions, right? For example, the one that's in the collection of knowledge and the ontological system, right? Even when there's the first approach, like when you say, okay, I have these 5 symptoms, like 20 doctors will likely have 20 answers.
Yes.
Or 20 hypotheses, which will then lead to, for example, 20 different subsequent questions that they ask. So it needs, so whatever is that magic that's happening inside the head, if it is not fully sort of ontologically captured,
Correct.
which means there is a lot of variability in the first step that you itself took, which would also lead to multiple paths for convergence, right?
Mhm.
So I find that idea itself quite interesting, that how do you get that right? How do you harvest expertise from around the world to be able to reflect that into a decision system that's, a knowledge graph based decision system, right?
Yeah, yeah. So the subjectivity, how do you separate the subjectivity from objective knowledge, right? So
Mhm.
if I look at the medical textbooks, the standard medical textbooks, every disease has a very straightforward template, right? Which says these are the symptoms, these are the primary symptoms, secondary symptom, whatever. So we don't only talk to the doctors, we talk to the textbooks first, mine that data, and then say this is the proper knowledge, objective knowledge about this domain.
Mhm.
On top of it, then we go to the advanced doctors and say, what do you think? And they fine tune this knowledge based on their experience. So we start with the pure knowledge system and we fine tune that with the experience of doctors. And then, even today when we build let's say, a radiology system, we ask the same X-ray to 3-4 radiologists and see what disagreement they have, because it is still a subjective art, not a science, pure science, right?
Yeah, I mean, picking the feature itself is like subjective, right?
Correct. So the idea is subjectivity in these complex domains becomes the baseline for AI to crack. And if AI can do better than how 2-3 people are, disagreeing, that means we have reached a level beyond them, right? And now as we
Yes.
connect, the next thing that
Provided, however, that the primary data that we are using as a basis for teasing this apart
start with something
itself is canonical.
Yeah. So we need to start with a ground truth which is well established, and therefore the medical textbook, right? In every domain there is a ground truth, a nice, perfect knowledge, and then it is refinement on top of it, is subjectivity, and learning and experience and contextualization will come later. But we have to start somewhere. Yeah. And this cycle that we keep talking about is important. How do you start the cycle is important. But removing subjectivity is one of the goals of, AI thinking and reasoning. And that's what we do when we, remove subjectivity, even in our diagnosis. We reduce the distribution ambiguity, right? Entropy. So these are the general principles of diagnosis. Right? Same thing Sherlock Holmes does, same thing, a mechanic does in a car. Diagnosis is a general system thinking. Human diagnosis is very complex. But diagnosis as a service is a broad field, especially airlines or whatever complex systems that are out there.
And what do you do about the translation layer when somebody is translating their so-called symptoms into language, right? So, and then detail, right? I mean, you might be having N symptoms, you might only be able to articulate 2 of those.
Correct. And
and then the flip side is when, for example, a doctor asks you leading questions to narrow down possibilities, you don't even understand what the doctor is saying. So your answers either are, misinformed, right? Or you missed stuff.
Yeah. So we have
despite the existence of an objective truth,
Mhm.
this process is highly error prone, right?
Yes, it is. It is. So what we have done is we have made sure that that kind of error doesn't happen in 2, 3 things we have done. One is we said no NLP. We will
Okay.
give you a pre-canned question and a pre-canned answer. It's a multiple choice. So you don't have the ambiguity of NLP.
Mhm.
Second, does the question appear canonical or normal or colloquial or too technical to you? So if I say, do you have abdomen pain? Now, half of the people don't know what is an abdomen. So I have to say,
Correct.
do you have a tummy pain or a stomach ache? So
Mhm.
these are the kind of things we do on the UI UX side by going through a lot of usability studies and seeing whether even an English speaking advanced patient in an urban environment finds this canonical, because doctor doesn't talk to a patient in a technical language, right? They may talk to each other in a technical language. They may say some kind of a complicated disease, which actually means some simple thing in our world, but it's a complicated name in their world, right? So the idea is that is the second thing which we have to do, simplify the language. When we go to multiple languages, it will become even more interesting. Aapko bukhar hai kya, right? Do you have fever, right? Kitna bukhar hai? So how do you translate this into other languages? How do you allow for English mixed languages in that? Because that's a canonical. So these are some of the product design questions that will keep coming. And a lot of usability studies have to be done in villages, in tier 2, tier 3 cities to make sure that we are producing the right questions in the right language that people can understand, right? So that error does not go. The third thing you said is very interesting. I'll give you a anecdotal evidence around that. So what happened, we went to some very senior person in a senior place I don't want to reveal. And he's a good doctor. He said, we were putting symptoms A, B, and C, and he asked us to remove the symptom C. He asked us to remove the symptom C because he wanted to test this system. So then we said, okay, A and B, and we started running the triage. And then it asked a question D, then question E. And the doctor had a disease in mind, and he knew that symptom C must be there. And then after 3, 4 questions, our system actually asked the question C, which he had removed. And then that guy was completely convinced that, wow, this is now, even if I don't tell you the symptom early on, the system will figure out that you must have this symptom because you are heading in a certain direction, right? This is the power of a holistic thing. And we have to test it many, many times over every disease to get it right, to make sure that it does the right thing. Yeah. Because lives depend on this. So it has to be 100% accurate and all of that. Yeah. But yeah, so the system should be robust. It should be easy for people to consume, right? And non-technical, and it should be accurate, and it should be efficient in its conversation. Not 200 questions, right? By the time the person failed about, he'll forget why he's there, right? He's just asking questions after questions. Okay. All right.
Absolutely. Super. Lovely to have had you here, Shailesh.
Thank you.
Thank you.
Great always to
We'll
come to
continue to
unit.
bother you.
And,
Yeah.
Yes. Thank you.
And
right.
and about hiring as well as some other questions, I'll get back to you.
Yeah.
Okay?
Please. Yeah. Send me some.
Cool.
Yeah. Okay.
Yeah.
Thank you.
Thanks a ton.
Yeah.
Bye.
Bye-bye.